So earlier on we're looking at the displacement at key areas of the circumference. So when the particle moves from here and then comes here, that at the time there is t is equal to big T, the period on 4, which will be equal to, we know omega to also to be equal to 2 pi on T. So when you substitute omega, you have 2 pi on T times T on 4. This and this is true. So now we have y is equal to a sine pi on 2. What is pi on 2? Pi on 2 is 90. And 90, sine of 90 is equal to 1. So it means that at the time t is equal to pi on 4, the displacement y is equal to a. And we saw it. We saw it that when the particle moves from here and then comes here, the displacement of the particle is equal to the maximum displacement, which is the amplitude. And mathematically, we have it as well. Okay. Now, when the particle comes here, the time to reach here is big T on 2. So at big T on 2, what is the displacement? Y is equal to a sine omega t. Omega is 2 pi on t times t on 2. So we have 180. Sine of pi, which is pi is 180. Alright. We got 2 pi is 360. So 2 pi is equal to, sine of 180 is 0. Sine 180 is 0. So it means the displacement over here too is 0. Yes, and we saw it. When the particle moves from here and gets here, the displacement, when you trace the displacement, of the particle to the y-axis is equal to 0. The mathematics also says it. Let's look at when the particle moves and then comes here, what's the displacement? Of course, it has to be the other amplitude. But let's see. So at t is equal to 3/4 of the period. 3/4 of the period. We have y is equal to a sine 2 pi on t by 3/4 of t. And pi on 2 is 90. Sine 90 is 1. So we have the amplitude as well. So when the particle gets here, the displacement is equal to the maximum displacement, which is the amplitude. The mathematics says it all. Then at t is equal to t, complete revolution. What is the displacement? Y is equal to a sine 2 pi on t by t. Alright, so we have sine of 360. 360 is equal to 0. So y is equal to 0. So when the particle gets here, the displacement along the y-axis is 0. So beautiful. Is that okay? So we can use the mathematical equation to determine the displacement of the particle at any time of its motion. And we can also use the displacement along the x-axis when it is displacing, the object is seen to be displacing this way, to prove the whole thing. A cos omega t. To also look at um, the displacement of the particle as it oscillates back and forth along the x-axis. Okay, the difference between the displacement along the y-axis and then the x-axis is here. At t is equal to 0, the displacement for y is 0, just as we saw. But at t is equal to 0, if you are looking at the displacement along the x-axis, it will be equal to a, the maximum amplitude. So what it means is that if you are plotting this, the displacement function y on t, this is how it's going to look like. And I want you to spend time to follow this up with me. The amplitude, and then this is the other amplitude minus this is y, of course displacement. So now let's look at time t is equal to t on 4, time t is equal to t on 2, time t is equal to three-quarters of it, and then t. How would the displacement function look like? So at t is equal to 0, we realize that the displacement is 0. So this is, let me adjust my board a little bit. This is t. At t is equal to 0, the displacement is 0. So we start from here. Then at t is equal to pi on 4, the displacement is y. So this graph will rise, and then at t is equal to pi on 4, the displacement y is equal to the amplitude. So that's it. At t is equal to half. T is equal to half of the period. The displacement is 0. So this graph will fall to 0 at this. Will fall to 0 here. Then at t is equal to three-quarters of the period,